Good morning to all of you. Welcome back to Physics STPM. Let us start with our today's topic. Okay, today's topic is scalars and vectors, 1.3 in the syllabus for STPM student. Right? Supposed to determine the sum, scalar product, and vector product. A-level student just need to determine the sum, that means adding and subtracting vectors as well. Then resolve a vector to two perpendicular directions. This is another method to find the resultant vector. A-level syllabus is 1.4. Understanding the difference between scalar and vector quantities, and give example of scalar and vector quantities. Included in the syllabus, add and subtract coplanar vectors, that means on the same surface or on the same plane. Present vectors as two perpendicular components. Right? Let's look at adding and subtracting vectors. What is a scalar and what is a vector? A scalar has magnitude. Example, mass, time. Right? Can think of others, can be speed, can be distance. A vector quantity has both magnitude and direction. Example, velocity, acceleration, force. So you should be able to state which of the following are scalars and which are vectors. For your A-level or STPM, you need to recognize if it's a vector, use a vector method to find the resultant. If it's a scalar, use it as a scalar. So you should be able to identify, right, from what you have studied in your O-level or SPM, which is vectors. Right? This is a scalar. This is a scalar. Potential difference is also a scalar. Length is also scalar. Kinetic energy is also scalar. Volume also scalar. Temperature is also scalar. Right? Only vector is force, moment of a force, momentum, electric field strength. Right? So all these are scalars that are circled. Right? Vector is a directed line segment. It's just a line directed in one direction. So we can represent it as symbol. That's the O way. Right? Different way. Right? This is O phase. Right? This is also O way. That means it's from A to B. The vector is from A to B. But you need to, for A-level STPM, you need to recognize it's a vector. You use a vector method to calculate the resultant. Right? You don't need to show all these curly things. You need to recognize them. Textbook will use boldface, very dark letter. Right? So in this case, from A to B, that's the arrowhead. Right there. Right? So if it's a vector, it must have a direction. Right? In this case, there is 50 meters per second, 60 degrees. So it's south, 60 degrees west. Right? Vector must have magnitude, must have direction. Or another way of stating it is we reference to the north. That's the north. That's the east. So this is 180 degrees. Right? Plus 60 is 240. So we can say that it's 50. Right? It's moving at 50 meters at a bearing. Right? Bearing we always take from the north. 240 degrees. Right? Or some prefer to use this way, funny way of saying west or south. This is south, west or south. Right? South, west or south. Okay, these two are more common. Okay, must know your direction. Equal vectors. Two vectors are equal when they have the same length and parallel. That means same direction. A equals to B, That's the arrowhead. That's your A, that's your B, same length, same direction. And the end is called the tail. Negative of a vector. Right? We write as negative A. If A is a vector, then negative A is it has the same magnitude as A, but opposite direction. Right? Negative means opposite direction. Right? If that's your A, then we just draw the same length, but opposite direction, minus A. Vector equation. Addition of two vectors is a single vector. Right? 2 to get 1. And that 1 is called the resultant vector. The single vector is called the resultant vector. The resultant vector R has the same effect as the two vectors. It represents the two vectors. It has the same effect as the two vectors. Addition of A and B, vectors A and vector B, we write equation R, the resultant. It can be A plus B or B plus A. R is the resultant vector. Right? We can add the vectors in any order. It's called commutative. Doesn't matter with A plus B or B plus A. Okay, so if you are given a vector A, 30 degrees to horizontal, and B is horizontal, there's a head, there's a tail. You can use triangle rule on a method to find the resultant. The first thing is to draw. Right? This one will tell you draw A first. Right? There's your A, vector A. Right? An angle of 30 degrees to the horizontal. Draw vector A first with magnitude and direction. At head of A, add the vector B. At this head there, add your vector B. The B. So that is where you start to draw. That's where you end. Your arrowhead is where you end. Right? You draw this way, you end here. So the resultant vector is where you start and where you end. Join that together. Right? Where you start, where you stop, you join that, that's the resultant. Right? The arrowhead must be from where you start to where you stop. That's your arrowhead. That's the resultant. Or we can use parallelogram. Two sides parallel and equal. Two sides parallel, and these two are equal in length. And that's the diagonal. It has two diagonal. The other one is here. Vector addition, we use parallelogram method. Now we are just studying different method of adding vectors. Right, we got vectors A and B. Sometimes we write capital A, capital B, or small a for B. First step, start the two vectors from the same point and draw the vectors. Right, roughly the same length. Roughly the length of the vector given. And then that's your B. Then complete the parallelogram. Okay. Complete the parallelogram. This side parallel to that side. This side parallel to that side. And then the resultant is from this end. Same method. Right? They all start from the same point. That's the resultant R. R equals to A plus B. Depending on where you look. You look from A, here is A and plus B. You look from bottom there is B plus A. Okay? These two are parallel. Remember that these two are parallel. What are we doing? We are replacing two vectors with one vector called the resultant. This single vector called resultant has the same effect as the two vectors. That's all. Right? It's easier. Rather than think of two vectors, we think of one, then we can see the direction and the magnitude. Right? But we cannot do it. What is wrong? Cannot do it this way. Cannot take from arrowhead to arrowhead. It must always be from where the two start. start from a common point. Imagine a towboat. This is a boat. These are the two that pull the barge. It's going in this direction, going in that direction. So of course the resultant pull direction will be here, the force will be here. Right? If both of them are the same, then it's a diagonal of the parallelogram. Right? That's why we don't accept that. Ship, there's your ship. Pulled by two boats. Right? Tip to tail method to find the resultant. Okay, come here, not there. Not there. Subtraction. Let's say we can use the two vectors. This is your B, this is your A, 30 degrees horizontal. We can rewrite that. Instead of A minus B, we can say it's plus minus B. Add to vector A the negative of vector B. So that's your vector A. Right? We can use triangle rule or can use parallelogram rule. Same thing. Start with vector A. And to the head of vector A, add minus B. This is plus B. Right? Same B. That's plus B. No, we don't want that. We want minus B. Minus B. That's your minus B. So that's where we start. That's where we end. That's the head of the second vector. So we join from where we start to where we end. Where we start to where we end. That's the resultant. Or S. S for subtract. Resultant vector represent these two vectors A minus B. Scalar and vector product. This one is not for A-level student, but you are going to university doing physics, and you will make this more often. Right? Rather than teach you about Leibniz left-hand rule or that, you use a scalar vector product easier rather than too many rules to remember. Right? If it's a scalar product or dot product, right? Put a dot there. Vector times vector can be a scalar or vector. When two vectors are required to be in the same direction, right? That's our form of definition, then it's a scalar product. Example, work is force times displacement, or force times distance move in the direction of the force, then we call that scalar product. A dot B. Right? So it's usually we resolve A in the direction of B. Right? So this is A cos B. A cos theta, that's the angle theta. So multiply these two together in the same direction. A B cos theta. Whenever we see cos theta, we know it's a scalar product. And remember, theta is the angle between the two vectors. Right? The other one is called vector product. You have A, you have B, and there's a resultant. C is A cross B. Right? Important, not a dot. It's a cross. We must be able to distinguish this as a cross. That's why it's called vector product or cross product, because it's a cross. Right? Here, we are interested to multiply two vectors, and the third vector is perpendicular to both of them. Right? We write it as C times C equals to A cross B. And usually, you will get AB sine alpha as the magnitude. Okay, so to illustrate the point, the hand, okay, let me just okay, if you can remember the two vectors I've mentioned, two vectors that I've mentioned. Okay, These are the two vectors. Okay. This is your, if you want, this is the first vector, this is the second vector. Okay. So if you cannot see that, can we redo that? Okay. This is the first vector, this is the second vector. Okay. And all you need to do is the third vector is always perpendicular to the surface. The two vectors doesn't matter about this angle. They will form a surface or a plane. The third vector is always perpendicular to the plane. So it depends on which is the first one. If this is the first one, then you, sorry, if this is the first one, okay, then you, let me just, okay, this is the first one, then you put it here, perpendicular to the surface, so it's going up. Right? The palm of the hand must be facing the other vector. It's always in the direction of the first vector. First vector. Right? Facing that, so you can curl to the other vector. So the direction of the third vector, the thumb. Okay? Or if you take this as the first vector, right? Sorry, this is the first vector, then it should be at the bottom there. Okay? Facing, right? The blue one, the blue pen, facing the other pen, the orange pen. Right? Facing that, so it's going towards that. Okay? So it's important. These two vectors will form a surface or be on the surface. Right? So if we start with this one, okay, then it is facing the other vector, this vector. Then the third vector is up, perpendicular to this surface. Okay, so let's carry on. In fact, it's easier rather than memorizing too many rules. Okay, you can now just put it straight there, the hand there. Right? These two will be on the surface. This one tell you A comes first. It's important when it comes to cross product. Which vector comes first? A comes first. A comes first. So you put your hand along A, the palm facing the green vector, and the thumb perpendicular to the surface is the direction of the third vector. Okay. Right? Some author will call it right hand curl rule. All right. The right hand points in the direction of the first vector. This is the first vector. Vector A, and then the fingers must be able to curl to the second vector, and they are in the right direction. The thumb is the direction of the third vector. Example, Fleming's left-hand rule. Well, you don't need to know about Fleming's left-hand rule as long as you know this vector method, vector product method using the hand, one hand, that's all. Too many, right? Too many rules, very hard to remember. If you use a vector product method, right hand, then it's easier. Right? Example, this one, V times B. Right? That's your charge, that's your velocity of the charge, that's the magnetic field strength. Right? So this is a force on a moving charge, positive charge Q, moving velocity V at an angle to the magnetic field strength B. Right? So you can see it's important. If it's B times A, then the direction of C is downwards. Right? This is from A to B, A to B, right? A to B. Right? A to B. A is there, and to B. Okay. Right? So A times B, A cross B, not times A cross B equals to minus B cross A. A sine, right? AB sine theta, that's the magnitude. is the area of this parallelogram or rectangle. If these two are perpendicular, it's a rectangle. If these two are at an angle less than 90 degrees or more than 90 degrees, then it will be a parallelogram. Right? Important. Order of vector is important. Right? You can see the example. Okay, there's the velocity of the charge. There's a charge here. There's a magnetic field strength. Right? So it's a vector product. V times B. So V first, facing B. Right? So you draw that, it's coming out of the face. Right? Coming out. You will treat the screen as a surface. Then your fingers pointing to V, pointing in the direction of V, and then the pump, right? Pump facing B. Then the third vector force is coming out. Okay, so that's the force acting on the lossy charge. Right? So if the charge is negative, then you can take the direction as the opposite direction. Right? You study this in your semester 2. Okay, you can use curl rule or right hand palm rule, same thing. It's just to show you. Or it can be a conductor. Right? L is taken as a vector. So the current, the direction of the L is the direction of the current. L cross B. So same thing. You can think of L and B as a surface. Right? There. Surface there. The screen there, as the screen is your surface. Then it's coming out. Right? L pointing to B. L pointing to B. So the third force is coming out. Point direction out to outside. Point out of the screen. Got paper, then it's point out. If you draw on a piece of paper, then it's going up. Okay. Okay, so there's actually the force on the conductor. Okay, example, we define our magnetic flux as B dot A. Right? This is a dot, not multiply, dot, important, not a cross product. A is the area of the surface, and usually we call the vector A as pointing outwards. Right? We treat area as a vector pointing outwards. And this is a scalar product, B dot A. So we want both of them to be in the same direction. Okay, B dot A. Scalar product of B and A, vector B and vector A. A is pointing perpendicular to the surface, that is B perpendicular to the normal, if you like. So in this case, we see BA cos theta. It means we want B in the direction of A. So we resolve B in the direction of A. That's why we got B cos theta. Okay, or it can be A in the direction of B, same thing. Right? We just resolve A in the direction of B. Okay, so these are things that you need to remember for this topic. You haven't completed yet, still got 1.4. This is how you find the resultant. We are now going to discuss soon. Let's do some example first. This is called polygon rule. Right? It doesn't have to be 2 vectors. It can be 3 vectors, 4 vectors. But you just draw at the head, draw another one. At the head, draw another one. Okay. The resultant is where you start and where you stop. That's the resultant vector. Okay, let's look at some example. You need to know what is scalar, what is a vector. Yeah, scalar quantity has magnitude only, no direction. Vector quantity have both magnitude and direction. Right? So if it's a scalar, the speed of a car changes from 50 to 80. We know there's an increase. Right? So 80 minus 50. The answer is B. The speed increases by 30 kilometers per hour. Right? This one is just subtracting or adding vectors, and you need to know how to distinguish, right? Identify which is scalar, which is a vector. So which one of the following pairs contain one vector and one scalar? Right? So B, power is a scalar, force is a vector. So vector are your displacement, acceleration, force, momentum, velocity. These two are both scalar. Okay. The diagram shows an arrow representing two vector quantities. These are from A-level, partial paper, Cambridge A-level. Which diagram shows the resultant? Right? Can start with anyone. Can start with this one. Then add this one to here. Triangle rule. Then see which is the right answer. You can use parallelogram rule. Same thing. Right? The answer in this case is donkey. Forces of 4 Newton, 6 Newton act at a point. Which one of the following could not be the magnitude of the resultant? So there is no direction. Right? Which could not be. Right? If you add them up together in the same direction, 4 plus 6, the resultant is 10. 4 plus 6. Right? That's the largest you can go. If you subtract them, 6 minus 4, then the resultant is 2. That's the smallest you can go. Right? So you cannot get 1. Right? You put it the 2 at an angle, 6 plus 4. That resultant there R, right? From the starting tail to the head there, that R is must always be less than 10. Right? You can just play with it. Always less than 10. Right? It's between 2 and 10. So the answer is A. Cannot get 1. Right? It's just to show you again the same thing. Right? The resultant of 4 and 6, same direction, 10. Opposite direction, you subtract. Now it's 2. So at an angle, 6 and 4 at an angle, it cannot get more than 10. It must always be less than 10 or more than 2. Right? In this case, you are required to find the resultant of 2, 19, and 5. So the easiest way, this is partly like component method, right? We will study in a while. Right? 5 is subtract, 19 subtract 2. So you still got 17 in the right direction towards east or right, towards right. Then form a parallelogram or rectangle, and that's the resultant. Okay? Then can calculate out using Pythagoras theorem. This is 17, this is 5, 17 square plus 5 square, square root that, get 18. So the answer is donkey. Right? Two vectors F1, F2 act at an angle between them theta. Which combination would result in magnitude of 1 Newton? Yeah, you can play with your pen. You can use your pen to play with it. Play with it. Right? Parallelogram here, it will be longer, the resultant will be longer. So you can move it around. It cannot be that way. That way it becomes smaller. Right? Parallelogram is going to be smaller. So it must be somewhere around there. Right? Somewhere around there. Right? There is a parallelogram that we are looking for. 1 Newton, 1 Newton. Then we want the resultant 1 Newton. Right? The resultant 1 Newton. So if that's 1 Newton, this 1 Newton, this 1 Newton, then this becomes an equilateral triangle. Or this is a rhombus. Okay? So this is 60, this is 60, this is also 60, this is 120. Right? So answer is B. Then we look at the other two see that the others cannot be the answer. Okay, the two of them less than 90, less than 90. Okay, the resultant is that longer. Okay, now, longer than 1 Newton. Okay. 2 and 1 Newton less than 90. Okay. If it is 0, then it can only be 1. But if it's less than 90, it didn't say 0, so it cannot be 1. It must be more than 1. Right? 2 Newton and 1 Newton, more than 90, but less than 180 degrees. Right? 2 Newton. The other one is 1 Newton. Right? So we can see that this one cannot be 1. This one is likely to be more than 1. This one, more than 1. Okay, let's try a subtraction. 2 possible displacement of the object represented by vectors P and Q. Which vector best represent the resultant vector P minus Q of the object? Right? So you start with P. Right? Start with P. Remember, subtraction means P plus minus Q. So you start with P. Right? You can use parallelogram rule. Parallelogram rule is the same point. Right? This one is plus Q. This is minus Q. To complete your parallelogram, right? Complete your parallelogram, we can draw it here. Parallel, and there's a resultant. P minus Q. So answer is donkey. Right? Three wires exert a horizontal force on a vertical pole as shown. Which vector? These are the 3 forces, 3 vectors acting on the wire. Which vector diagram shows a resultant? You can start with any point. Okay, you can start with this one. And you can add this one. Then you can add this one. Draw roughly the same length. This is longer, roughly the same direction. And there's your resultant. Then you go and choose. It cannot be these two. Most likely this one. This one is too long. Okay. Vector answer B. Okay, let's finish off with G. Resolving a vector to 2 perpendicular components. Right? Previous method and this method is a way to find the resultant vector. We find sometimes this way method using component method is easier. Sometimes using the other method, triangle rule, is easier. Right? So previously we learned to find a resultant vector from 2 vectors. Right? F is the resultant, A plus B. Right? We form a parallelogram or rectangle in this case, and that's your resultant. That's your angle. Right? So instead of these 2 vectors, we represent with 1 vector with a particular direction to the x-axis. But now we are going to look into 1 vector is given. We find the other 2 vectors A and B. Right? Same thing. Right? We always prefer perpendicular, easier to calculate. Right? Fy in the y direction. Right? Fx in the x direction. Right? And we remove the force. Same thing. Finding the component of a vector. Here we are given a vector at a known angle, force F, vector force, at an angle theta to the x direction. And the 2 components. Right? Y-axis can complete the y-axis, the x-axis, complete the rectangle. Right? And there's your Fy. Vertical is your Fy in the y direction. right? Component in y direction. Right? This is also Fy. Right? Parallel. Fx. Right? This is Fx. Right? In the x direction along the x-axis. Right? We can call it Fy, component of the force in the y direction, or vertical component. Right? So vertical component this side. Okay, far away from this angle is F sine theta. Right? This is a component of F in the direction of X, or horizontal component. So it becomes F cos theta. Right? You prefer to use the old-fashioned method. Easier you can remember. Far away from this angle, F sine theta. F cos theta if it's next to this angle. Now you can use sine theta. It's not wrong. It's just a bit a step slower, that's all. So Fy, this is Fy. Fy over F. Right? Get that one there. Same. Cos theta is just your Fx over F. That's all. Same thing. Right? So instead of having one vector, we find a component in two perpendicular directions. Instead of F, in this case F, at an angle theta, we replace it F sine theta, F cos theta. These are two components. Usually at a right angle, easier. We want to make things easier for us, not at an angle. Right? So you need to know all these maths. Right? Law of sine, law of cosine, how to use this formula. Okay, let's solve one example. Right? There's your pendulum bob. Right? The weight is 50 Newton. You can draw 50 Newton. There's your string attached to the ceiling. Right? And then you pull it to the right at an angle of 30 degrees. This is 30. This is vertical. This is also vertical. So these are alternate angle, 30 degrees. Right? You are given tension, the string is 38 Newton. Determine when it is released, the resultant vertical component. Right? At the point where it's released, there's a resultant vertical component. So 50 can draw, 50 can resolve this 38. One will go vertical, one will go horizontal. Right? 50 horizontal, 38 far away from this angle. Far away from this angle, so it's 38 sine 30. Right? Calculated 19 Newton. Right? This is 38 cos 30. Right? Next to the angle, 38 cos 30. And you can simplify this one. It's still the same. There's no others on the other side. You can put as 30. Right? That one is greater, 50 minus that one there. So 50 minus 32.9 is 17.1. Right? Complete your rectangle. That's your resultant. Okay, resultant vertical component. So it's right, as long as you show the direction here, you are quite safe. It's downwards. Right? Downwards, 50 minus that. 17.1 downwards. Resultant horizontal component. Right? Resultant in a horizontal direction. It's only one only, 19. Resultant initial force. Right? When you release it, that's called the initial resultant force. So these two, using Pythagoras theorem, these two, right? This one and this one, using Pythagoras theorem to find this resultant. Okay, that's what we found. Right? Part C. Okay, two perpendicular direction. resultant force is Ry, right? This is your Ry, this is your Rx, that's your R. Put in your value, 17.1 is this one, 19 is this one. And this is your calculator to calculate out, it's actually 19.0. Right? And it must have a direction. As long as you show where your angle is, you are quite safe. Right? It's understood. You can use tangent, or you can use sine or cosine. You can use R if you want to. Right? This is 17.1. This is also 17.1. So it's tangent 17.1 divided by 90. Using a calculator is 42 degrees. Right? Work with 3 significant figures if you want, round off to 2. Right? Inclined plane, there's a plane, your surface, your plank if you like. There's horizontal, there's an angle theta there. Right? Geometry involved. Normal is a line perpendicular to surface, so there's your normal. Right? It's 90 degrees. Right? That's 90 degrees. And then you have this one vertically coming down. So this is 90 degrees also. Right? Vertically downwards, 90 degrees, this one. Angle is 90 degrees. So this angle is, right? This angle plus that angle is the other 90 degrees. Because 180 minus 90 is 90. These two to add together is 90. Right? This is 90 minus theta. So this is also 90. Right? Normal to the surface, 90. So this one must be theta. Okay? Theta plus that, this is 90. Right? Important. That is theta. Memorize it. Okay, it's the same thing. I just displace a point there to up here, that's all. That's your block of wood, or wooden block, or weight W, resting on the surface there. Okay, now for a person pushing a wheelbarrow up a slope. Right, so there's your plane. Make it an angle of theta to the horizontal line. Right, as I say, we want the motion is likely to be up or down the plane or vertical. Right, cannot come down horizontally because the plane stop it. So that's the reason why we resolve it perpendicular to the plane or parallel to the plane. Right? So that will be W perpendicular to the plane, component perpendicular to the plane. We put a perpendicular, help us, and this is theta. Right? That's your parallel. Right? Two parallel line, parallel to component parallel to the plane. Right? We will be using this later on as we study physics. Inclined plane. So parallel, you must be able to recognize. Right? Far away from this angle, so it's W sine theta. Perpendicular to the plane. Right? W cos theta. That's your W. That's the resultant. One force there, we solve into the component. Okay, W cos theta. For example, find a there's a force, there's an angle to the x-axis, 53 degrees. Right? Simple one, you should be able to do that. Component in the horizontal direction. Right? F cos 53 using a calculator, 3.01 Newton. Vertical component, F sine 53, 3.99 Newton. Okay, this doesn't have to be tied down by an angle. It can be, the angle can be at 60 degrees to the vertical. Then you can be asked to find the horizontal component. Okay, so you should be able to do that. Right, far away. This horizontal component is far away with this angle, so it's 5 sine 60, 4.3. So answer is 20. Right? Sometimes it can be just as simple. Two forces at a point as shown. This is O level. What is the size of the resultant? Find the component in the x and y direction, or vertical and horizontal direction. Right? So 8 minus 4 is 4 to the left. That's all. Right? Vertically, 2 minus 2 is 0. That's all. The answer is B. Right? Or it can be that way. So same thing. You find your horizontal 8. Right? 8 is longer. Minus 4. You still got 4 to the left. And 5 is greater than 2. So you still got 3 to the vertically outwards there. 3. And complete your parallelogram. That's your resultant. Okay. Using Pythagoras theorem, this is 3 also. 3 square plus 4 square is 5 square root that. 5 square square root that becomes 5 Newton. And you have, remember, it's a vector, so you must have a magnitude, then you must have a direction. Right? Tangent theta is 3 divided by 4. Theta is 37 degrees. Right? So a wooden block of weight 20 Newton is placed on an inclined plane. The plane is inclined at 30 degrees. 30 degrees. What's the component of weight down the plane? Right? Remember, this is normal. This is parallel axis. So remember this 30 degrees. Right? So that will be parallel to the plane. So it's far away from the angle. Right? So it's 20 sine 30, which is 10 Newton. A. Okay, this is just to show you, drawing a bigger picture so you can see clearly. Okay, or we can have 3 coplanar forces of magnitude 20, 40, 50 act on a point P. That's a point P, sorry. That is your point P. Yeah, slightly displaced. Okay, that's your point P. Which one of the following is the approximate bearing of the additional force required to maintain equilibrium? That means you don't want resultant, you want equilibrium. Equilibrium is same direction, same magnitude as the resultant, but opposite direction, that's all. So you have to find the resultant first. Right? So these two, replace that. 50 minus 20 is 30. 40 is there. Okay, so that's your resultant. Is 30. 50 minus 20 is 30. That's 40 hours there. Complete your rectangle to find your resultant. I can find this angle theta or this angle, whichever you prefer. But since they want bearing, right? They want bearing, then it's better to find this angle theta, so they can find this angle theta. Right? This is the force required for equilibrium. This is the resultant. Right? So tangent, this is 40, this is 30. So 30 divided by 40. See your calculator, 37 degrees. Right? Remember, we want force required for equilibrium. So it's the green one, this one, not the red one. So this angle is also 37. So 37 plus 180. Right? 180 plus 37 gets 217. So your answer is donkey. Okay, I hope you enjoyed it. Stop here. Right? We'll stop here for today. Thank you.